guys, this is Jadav. I am a student at IIT Kharagpur. So in this video, we are going to discuss about gravitational potential. In the last two videos, we have discussed gravitational potential energy. And if you have understood gravitational potential energy, then it's a piece of cake for you to understand gravitational potential. And if you haven't gone through the last two videos, I have provided link in the description. Please go and watch them first. Then you will better understand what we are discussing now. So the gravitational potential at a point due to a point mass is defined as it is the total work done by an external force to displace a unit mass. This is important. To displace a unit mass from infinity to a point inside the gravitational field of some point mass or the source mass without any acceleration or without changing its kinetic energy. Okay. So the definition is simple. It is the total work done by an external force to displace a unit mass from the infinity to a point inside the gravitational field of some point mass or the source mass without any acceleration or without changing its kinetic energy. The definition seems very simple. It is same as the gravitational potential energy. The only difference is the mass is replaced with unit mass. Okay. So let's try to understand it more clearly. Let's say we have a point mass capital M here. Okay. And that is fixed. Consider a point P which is at a distance of r from the center of the capital M or the point mass capital M. Consider a unit mass at point infinity. Okay. Consider a unit mass at point infinity. So the infinity is the point which is outside the gravitational field of capital M or the point mass capital M. Now the potential, the gravitational potential due to this capital M at this point P is the total work done. It is the work done by the external force. It is the work done by the external force to displace this unit mass from this point infinity to this point P without any acceleration. Okay. The gravitational potential due to this capital M at point P is the work done by the external force to displace this unit mass from this point infinity to this point P. Okay. And the external force is what? That is equal and opposite to the gravitational force. Right? To bring this unit mass from the point infinity to this point P without any acceleration, we have to apply an external force that is equal and opposite to the gravitational force at each and every point. Okay, at each and every point on this path, so that the acceleration of this unit mass will become zero. Right? So the work done by that external force that we applied is the gravitational potential at point P due to this capital M. In the last video, we have discussed gravitational potential energy and we defined it as it is the total work done by an external force or an external agent to displace a particle having some mass from infinity to point P inside the gravitational field of some source mass without any acceleration. Right? So in case of gravitational potential energy, we brought a mass, a particle having some mass. The mass may be 1 unit, 2 units, 3, 4, 5 or 100. But in case of gravitational potential, that mass should be replaced with a unit mass. Okay? It is strictly a unit mass. Okay? Let's try to understand it again. We have derived an expression for the gravitational potential energy, right? So gravitational potential energy is minus G capital M, the source mass, small mass, the mass which we have displaced, by R. This is the finest distance between this capital mass and small mass, right? So this is what, if I have a capital M here and I have a small m here which are the distance of R, then this expression gives the potential energy of the small m at this point which is at a distance of R from the center of the capital M. Okay, and if I replace this small m with the unit mass, then that gravitational potential energy is nothing but the gravitational potential. Okay, I repeat it again. If we replace this small m with the unit mass, then that potential energy is nothing but the potential. Okay, so this is the expression for the gravitational potential energy. If I replace the small m with the unit mass, then that will be the potential. So the potential, gravitational potential is represented with V, is now equal to minus G capital M, and this small m should be replaced with unit mass 1 by R. So this is minus G into capital M by R. Okay, so V is equal to, V is minus G into capital M by R. So this expression gives the potential at a point which is at a distance of R due to the point mass capital M. Okay, this is the expression for the gravitational potential at a point P which is at a distance of R from the center of the capital M. Okay, this point mass capital M. Okay, in the simple words, we can define gravitational potential as it is the gravitational potential energy per unit mass, right? So I am writing it here. The expression for the gravitational potential energy is this. What I am saying is, the gravitational potential is nothing but it is the gravitational potential energy per unit mass. So my V is now equal to U by M per unit mass. So we have to divide the gravitational potential energy by this mass, right? So then this is equal to minus G capital M small m by R by M. I'm cancelling this small m. We end up with minus G into capital M by R, right? So the gravitational potential is nothing but it is the gravitational potential energy per unit mass, or we can say the change in potential is nothing but the change in potential energy per unit mass. Okay, so we can write this as U, gravitational potential energy, is equal to gravitational potential at a point P which is at a distance of R into the mass. Okay, if I have a mass capital M here, and if I know the gravitational potential at this point P which is at a distance of R, okay, if I know the V value, then if I have to find what is the gravitational potential energy at this point P, when I place a mass small m, then that will be nothing but U, gravitational potential energy at point P is nothing but equal to V, the gravitational potential, into the mass that we are placing at point P. Okay, so gravitational potential energy is equal to potential into small m, mass that we have displaced. Okay, so the expression for the gravitational potential is V is nothing but minus G into capital M by R. Okay, so this is end, and thanks all. Hey guys, if you like my video lectures, hit the like button, share and subscribe.